All right, welcome everybody to the last day of school. We have a topic to cover today, and the reason why we're covering this topic is because it is actually relevant to your Java program. The way that Java works on input with a scanner is you ask it for an integer, or you ask it for a float or something like that, and if it doesn't have one, like if you ask for an integer and the user types in squirrel, it throws an exception. Okay, and that's our topic for today, what an exception is, how to throw them, how to catch them, how to deal with them. There's also a function called hasNextInt in Java, and that's an alternative to using it if you don't want to use exceptions. There's a function called scanner. On a scanner, there's a function called hasNextInt, and that'll tell you if what the user's typed from the keyboard is an integer or not. And so you can use that. There's no like if not cin kind of thing. That's a C++ idiom. In Java, you either use hasNextInt or you just try getting an int, and if it fails, it throws an exception, and you catch the exception, and you print error or whatever. Okay. So that's a question I've gotten 5 or 6 times over the last couple days for Java rainfall. And so what we're going to do today is learn about exceptions, because it's relevant to not only the Java rainfall assignment, but also your Zybooks. Your Zybooks are due on Monday. So we're going to review exceptions today, what they are, how to make them, how to catch them, and so on. So yay, last day of school. Let's do this. So start off with a blank file. And the thing about exceptions is what you have to understand, that an exception is like returning from a function, except different. Okay, so if I were to make a function, like let's say I've got a function that returns the last in line, which is a D attribute. And we'll talk about what should be there in a second. Let's say you've got a list. You've got a list of integers. This is a list of everybody, social security numbers that Santa Claus is going to be delivering presents to this year. And there's 3 people Santa Claus is going to be delivering presents to this year. Person with social security number 111, 222, and 333. And we want a function that will tell us the last person that Santa will visit. Okay, so how should we pass? Let's put it that way. How should we pass Santa to this function? Okay, call by value, call by reference, or call by const reference. How should Santa get passed? What do you guys think? What's the right way of passing a non-primitive? Const reference. Yeah. So by default, you should pass things by const reference, unless you need them to change. If you need them to change, then by reference is fine. But by default, line, list. Okay. By default, const reference is kind of the way to go. If you want to make a copy of something, then you would pass it by value. This would make a copy of Santa if you needed a copy for some reason. So for non-primitives, or primitives like an int or a double or something like that, const reference is your default way to pass to a function. Oh. The other 2 options are there, and if you need them, it's not wrong. It's just only use them if you need them. Okay. So int x is equal to Santa.back. Back returns the last element in a list. So it's technically what this function is doing here. And then we will return x. Okay. So what is this function going to print? What do you guys think? I'm going to compile it. I'm going to run it. What's it going to print? 333. Yep, you're absolutely right. Now, the one thing you should always think of when you're, not the one thing, but one thing you should always think about when you're a computer science major is what could go wrong, right? So I'm sitting here, I'm looking at this function, I'm like, what could go wrong? When would my DO-inspired last in line function fail? What do you guys think? What if the list is empty? Exactly right. Anytime I do a .at, I'm always like, does this thing exist? You know? Like, even if it's like, you know, vector.at 0, that'll succeed most of the time, but if the vector is empty, it won't. You know, that'll throw an exception, kill your program. So you need to always think in your head, which is where you do most of your thinking, think in your head. What could go wrong? You know, and always just as you write code, there should be a moment where you're like, we should think about this. Like, what if the list is empty, right? And so you can handle it, right? So what you know so far. Well, let's see what happens if it is empty. Okay. What do you guys think is going to happen if we pass in Santa in a world in which everyone was naughty? There's nobody on Santa's good list, and we ask Santa, who are you going to visit last on Christmas Eve? But if you put a string in the list, you can't. The type system will enforce that Santa doesn't have strings in it up here. If you try doing it down here, the type system won't allow it either. Okay. That's one of the benefits of using C++ over JavaScript, where you absolutely could put a string into an array of integers like that. It stops you from having mistakes. Yeah, Bill. That's why types are so nice. It's there for a reason. It stops dumb mistakes. All right, so let's see what happens. We are going to print out who is the last person Santa's going to visit on New Year's Eve. Social Security number 0. Okay, well, not what I expected. All right, I expected that to segfault or, you know, something. Nope. Just return 0. Now, how do we distinguish that from, I don't know, 30, 20, 10, 0? Right? Looks the same to me. How do I, the user, know that Santa is supposed to visit person 0, or if that was just an erroneous artifact that was brought about by an empty list? How can I tell if I'm the user running the program? Check to see if, that's the programmer. But from the user's perspective, right now, can the user who's using the software know if there's actually a person 0, or if, like, the list was empty? Is there any way for the person running the code right now to be able to differentiate between? No, they can't. And this is why exceptions exist, because this function here promised it's going to return an integer, and there is no integer you can return that is accurate, right? Because if the list is empty, any integer you return is wrong. If you return 420, then Santa's going to be like, all right, I guess I'll visit whoever's social security number is 420 last tonight. There is no person to visit because everyone was naughty in 2021. Nobody deserves a present, you know. And so we have no way from this function to accurately return a value. Do you guys see this? Like, yeah. And so what you know right now is to kill the program, right? It's like if Santa's list is empty, then die, right? Like, just give up. Like, sorry. And this is actually okay, right? Like, and the reason, this is one of the reasons why I've been teaching you to do this, is to get you into the habit of error checking and, like, thinking about these things. and you know, you'd be like, you know, you all naughty or something, right? To get into the habit of error checking and vetting and like worrying about these kinds of things, and okay, there actually is a 0. So in this case, there is a 0, but if there's nobody, then it says you all naughty, nobody gets visited. Okay, and this is fine for a small program, but what if it's a big program? You don't want to just, like in Microsoft Word, you don't want to just quit the program if somebody types in it, like if a list is empty or something, you know, like if you try word counting a Word document that has nothing in it, you don't just like quit, you know, saying you're naughty, Bill Gates doesn't like you, and quit. Like if you try word counting an empty document, right? So root of C++ to not return anything. Better for back. Do the other containers throw errors? It depends. It depends, right? So if you have a stack, yeah, okay, there we go. Stack events named stack. You see out stack.top. Segfault. It'll just go to whatever is there in memory. There's nothing there, and it just very happily segfaults for you. So something, I guess. That's one way. It's like return the top int. You know. I mean, it's technically more correct than this. You know what I mean? Like this is bad. The standard library is like, we'll just make up a number, 0. You know. You just heard Santa die. Santa did not die. Yeah. So, you know, still not good. You know, the segfault. Like I would never write code, you know, really to and release it that way. Out of bounds. I know. So if you use the safe standard library, the safe standard library has a safe version of the stack class, and the safe version of the stack class will check to make sure it's it'll check to make sure there's something there before returning it. And if it's not there, it throws an exception. Okay. Silent errors, like returning 0 when there isn't anything there, is the hardest thing to find for bugs for later. Yeah, it really is. It really is. And so, okay, so what's the more proper way of doing this? So there's 4 kind of schools of thought when it comes to errors. Maybe more. I can name 4 off the top of my head. The first is like return a magic number, right? Which is kind of like a in-channel signaling. Kind of like, you know, when we're like entering numbers and we say type 0 to be done. Well, you better hope that none of the people you're adding to your baseball scores or whatever has a player number of 0, right? So for this, you know, maybe if Santa has nobody on the list, we return negative 999, right? Do you guys understand that? So, you know, and then we can check that if last equals the magic number, double equals the magic number, then we handle it properly. See out. Sorry, nobody was good this year. Otherwise, see out. Last. You guys understand? So, sorry, nobody was good this year. However, this won't work if somebody's social security number is negative 999, right? And in this case, actually, it'll work because social security numbers are all positive. And so half the numbers weren't being used. And so in this case, we actually could just return a negative number of some sort, and that would indicate an error, right? So that actually would work. This is a okay answer, right? Because there's no negative social security numbers. Okay. It might break if, code is expecting a positive number because it's a social. There's real possibilities for explosions later on down the line if you do that, but in a situation like this, it actually works fine. Okay. This is why a lot of find index functions return -1 when not found. Yeah. But they turn into unsigned values in C++, and so they become max int, right? Because they underflow and go up to that. So if you ever do string in pos, that's max int, and that's just a magic number they return. So if you happen to have a string that's 2 billion characters long, and the letter you're searching for was on, or 4 billion characters long, and the letter you're searching for was on 4 billion, you have no way of detecting that. It's C++. They just kind of assume that won't happen. Okay. So, return a magic number. Okay. Second idea is to die. Yep. Just call die function, quit. It works okay in some circumstances. Sorry, error occurred. If I'm making Pokemon for real, and I'm loading from disk and an error occurs, I'm just gonna quit. Like, sorry, I couldn't load my Pokemon database. Yeah, I'm done. Peace. You know what I mean? And the reason for that would be it shouldn't run. If I couldn't load any Pokemon into the game, if I couldn't load my graphics files or something, it shouldn't run. Like, we're done. Just print a diagnostic error message, on line 50 of Pokemon.txt. I tried reading this, and I was expecting an integer, and I got a string. Some diagnostic would be nice. And you quit. It's fine. There are some circumstances where you're just like, done. Yeah. Okay. Could you read the value as a string and convert it to an int before adding it to the list? That way you can enter done to quit instead of a numerical value. You could. Yeah. But we're just talking about general purpose errors. Okay. Third option is error no. Global error code. This is how C does it. Okay. So what happens is you do something like this. If Santa's size equals 0, then we set error no equal to 420. And then the rest of the code, it doesn't even matter what we return. We return 0, I don't know, whatever, it doesn't matter. And what we do is we call last in line, and then rather than using a magic number like this, we say if the error number equals 420, then sorry, nobody was good this year. You guys see that? So error no is a global value that all the standard libraries functions use. And the trouble is there's only one of them, right? So if you have cascading failures, like they'll overwrite each other and stuff, and it's not thread safe because there's only one of them. It's kind of the same as magic number, except it's not, because it's not actually returning 420 in last, right? This is actually global. This is a global value. And so you can return whatever you want in last. You can return 0. Doesn't matter. But every time you call last in line, you have to check to see if error no was set. And this is a very common mistake that C programmers make, which is they'll call a function and just kind of assume that it works. Every time you call a function, like, let's say you try opening a file in C. Every time you call fopen, you are supposed to check to see if error no is set. And in fact, if you go through the man page, it'll have the list of possible errors. So if the mode was not valid, error no is set to E invalid. If and you're just referring me to other sections meant to open. Here's all the errors that could be set. So when you try opening a file, you're supposed to check for all of these. That file already exists and you're trying to create it again. Your flags are invalid. You're trying to open a file, but it's a directory. It's like 4 pages of error messages. Ain't nobody got time for that, and so they just ignore it. So, they might just say if error no is set, just print error. Like they'll do something like this, like if error no, I don't know, sorry, some error occurred. Just something happened, and and if you're really like into it, like you'll do something like this, and you'll just print the error code. And then if you've ever seen a program where it's like program quit with error code 20, that's what it's doing, and so that's fairly common in C world. You just ain't nobody got time to have 4 pages. Literally every time you call anything in the standard library, every time you call a function in the standard library, you're supposed to check to see if error no is set afterwards, because it'll return something. No matter what, it'll return something. It'll return 0. I don't know, but you need to check to see if error no is set. It's like if you're gonna open a file, we just did that. What if you're gonna, I don't know, read from a file. There are 7 different errors that could be set by scanf if you're going to be reading from a file. So every time you read from a file, you check to see if error no is set. Do you guys see how this is kind of annoying? Like, it works. It works okay as long as you're not multi-threaded. It works okay. It's out of channel. This is a out of signaling, right? So it sends the error message not in the return value, but through some other means. Tedious process, and so a lot of people just don't do it, and that's the problem. With exceptions, you can't ignore it. That's the benefit of exceptions. Exceptions are a 4th way of doing it, and they can't be ignored. So if an error occurs, you throw an exception, and if you ignore it, it kills your program. Right? So it can't be ignored. Or if you do ignore it, it kills. Another way of putting it is if you do ignore it, it kills your program, so you can't ignore it. Yeah. All right. So, for example, if you say vector of integer is named vec, and you see out vec.at 0, what happens? What happens if you try accessing element 0 from an empty vector? What's going to happen here? You're back. Good. Out of bounds. It is out of bounds, but what happens? What happens to your program? Does it keep running? Error. Okay. It's an error, but what kind of error? It's an exception. So the way that .at works is it throws an exception if there is nothing there. If there was something there, it'd work fine. But because there was nothing there, it throws an exception, and it kills your program. So the way that exceptions work, exceptions are alternative ways to return from a function. All right. You either leave a function through return or throw not both. Okay. So what is happening here is that it is throwing an exception. Okay. If an exception is not caught, then it kills your program. But you can catch an exception with tryCatch, which I'll show you in a second. So here we got a vector, and you know, maybe we do some like maybe we do some user input here, and then we're going to try outputting the first element of the vector. Do we know if the user actually entered anything? No, we don't. Maybe they just hit done. So what we do is we wrap this in a tryCatch block. This thing throws an out of range error. So we're going to catch an out of range error. And we're going to call it porting off. You can call the exception anything you want. Typically we call it E, I guess. Or call it ODAL. There you go. So cout error. Something went wrong. What went wrong is otal.what. What? That's a function that tells you the error. That's the error message. So when you throw an exception, there's an error message embedded inside of it, usually. And that'll tell us what went wrong. Okay. But check this out. When we do this, it actually keeps going. Do you see that? It did not kill our program. Cout, moving on with our lives. Yeah. Did you guys see the difference there? It didn't quit the program. You see that? It didn't quit the program. Keeps going. Right? Moving on with our lives. You guys see that? If you catch an exception, it does not kill your program. What? What went wrong? Range check. N, which is 0, is greater than size, which is 0. So it tells you what went wrong. You went out of bounds on a vector. So you guys see this? So this actually does not quit your program. It does not call die. It throws an exception. Up until now, you haven't known how to catch it. And so it just kills your program, because if you have an uncaught exception, it terminates your program. If, however, you catch the program, you can just be like, oh, I went out of bounds. Yeah, cool. All right. And then you just move on with your life. Okay. Do you have to catch that specific exception? You do. Now, you can have multiple types of exceptions. Sure. So you could catch any exception this way. And that'll catch any exception. Or we can just do this. Like that. That'll catch any exception. Okay. What does otal mean? That's the name of the variable. I can call it whatever I want. It's traditional to use E. It's just a variable name. It creates a variable name. Okay. So typically we use E. Just like how vectors are named vec, exceptions are named E. Okay. So yeah, and so this will catch any exception. All right. You can throw things that aren't exceptions. So, for example, I could throw the number 42 if I wanted, and then then the program dies because I'm not catching integers. So if you want to catch absolutely everything, you can have multiple catch blocks, by the way. So you could catch integers also. See out. Int. But if you want to catch absolutely everything, you can use ... like that. All right. You guys see this? So you can have a tryBlock, and what the tryBlock does, it just runs, and if everything goes fine, it just runs, and then it'll say moving on with our lives. Okay. By default, when you have a tryBlock, it should just run fine, no problems. Exceptions are for exceptional cases. So only for errors usually is what I would say. Don't use it as part of your normal, like, oh, I hit the end of a vector. Like, read from a vector until I get an exception. That's bad coding. Don't do that. Okay, so you can do a tryBlock, and you can have multiple catch blocks, and they will, whatever you throw, it'll kind of match. So if I throw a 42, that's not an exception. Oh, but it is in it, so it does this. If, however, I threw a double, then I caught something else. IDK, I don't know. If I throw an exception caught, range check, you went out of bounds. And then if we don't have anything wrong, hello world. No exceptions in that, right? Just print out hello world. Then it just prints out hello world, moving on with our lives. But you see, because we're handling these errors, it actually just continues the program. So you handle the error, you move on, and so this is a very professional way of dealing with errors, right? So you don't just have to terminate every time. Our throws typically wrapped around an if statement. There's no if statement here. Yeah, there's no if statement anywhere in here. You can wrap them, around a while loop or something like for int I equals 0, I is less than 10, I plus plus. Okay. So yeah, you can wrap anything in a try catch block. You can wrap all of main in a try catch block, right? So odal is of type exception. Odal doesn't exist anymore. It's now named E. The art is formerly known as odal. Yeah. So yeah, this is it's a class, and it's a class that exists in. There's one header file called exception, and there's another header file called std_except. So there's the exception class, which is a generic error of some sort, and then there's std_except, which if you include it, you don't need to include exception. That has like more specific exceptions like runtime error, out of bounds error, overflow error, things like that. So you don't need to include both of these. I would just include std_except and just throw those kinds of things. So if I were to throw if I equals 5, throw a runtime error saying what should I say? What error message should happen on? Being too polite. You're saying hello world too many times. Overly polite error. Which is actually an actual error in a troll programming language. You have to say please occasionally to the programming language, and if you don't say it enough, it won't compile because you're too rude. And if you say it too often, then you get an overly politeness error. And it's not documented how many times you have to say please. Get help. All right. So, these are the 3 keywords for today. Throw. Throws an exception. try is running a block of code, and if an exception takes place anywhere within there, then it jumps to the catch blocks. And it tries matching the thing that was thrown against the catch blocks. Runtime error is a kind of exception, so it's going to call this one. If I were to throw an integer, it would do that one. And if it's anything else, ... means catch anything. Gotta catch them all. Now, why doesn't it do that? Well, there's a more precise match. So if there's a more precise match, it does that one. Okay. Do you need a try for a throw? A throw has to be enclosed in a tryBlock, but not necessarily in the same scope. It's much more common to, right? So like if I access vec.at like this, vec.at throws, and the tryBlock's in a completely different scope, right? This is a function off in the standard library somewhere. It throws, and then I have my tryBlock here, and so I'm catching it out here. So the way that exceptions work is that when you throw an exception, it goes up a scope, and it goes up a scope, and it goes up a scope, and it goes up a scope, looking for any try-catch blocks that match it. And once it finds one that matches it, like here, we're throwing runtime error. The for loop here is in a try-catch block, so it goes up another scope. This scope, remember, scope is a pair of curly braces. All right, this scope has a try-catch block. All right, cool. Does anything match me? Yes, it does. It stops there. If nothing is caught, if nothing catches it, it goes all the way up to the top of the C++ runtime, where there is a universal, try-catch block that catches the runtime error, prints the error message, and kills your program. So if you have any uncaught exceptions, it kills your program. Do you need a try for a throw? Absolutely not. Watch. If I just do this, terminate called, right? Because I didn't catch it, right? So throws. So that's going to go out of bounds, and then even though it went out of bounds, I catch it, and then and then it moves on with our lives. Note that it does not continue. It does not continue the for loop, because when this throws, it breaks out of the loop and it breaks out of the whole tryBlock, and it comes down here, prints out an error message, and then it moves on. Okay. So your last competency exam will be on all the topics we covered at the end of the semester, including exceptions. Because in the previous section, I had a bunch of students sitting here during lab time, not writing any code whatsoever. So I'm like, all right, I see how this is. So there's going to be a competency exam on this. Okay. So ask your questions now. And this is the version that's going to get recorded and uploaded onto YouTube. So if you ask a good question now, maybe the 12 o'clock students, when they realize that they have disappointed me by not doing anything during lab time, will watch it and will have their questions answered. Because they sat there silently for an hour, which kind of bugs me. Like, why would you just sit there for an hour staring at a blank screen? You know what I mean? Like, if you don't know something, just ask a question. I'm a nice guy. I'm not gonna get mad. I missed it. What does catchAnyException do? Well, it catches init. So if we were to throw the number 10, then what would happen is it immediately stops execution of everything in here. Everything within the tryBlock stops. The second you throw, it terminates everything within that tryBlock. It'll jump down to here because it skips over this one because ints are not exceptions. You just thrown it. It matches that. It's like, okay. It's then going to print to the screen, caught an int, 10. Then it bails out and it keeps going. It does not quit the program. Yeah. You would have to include a return inside of your catch if you wanted to stop the program. Sure. Or you could do a exit. Something like that. So now it doesn't say moving on with our lives. It just says caught an int and then it terminates. And that's a clean exit. Right? So in your Java rainfall code, what you can do to check for errors is just keep reading ints, and if you ever get something that's not an int, it'll throw an exception. You catch it, you print bad input, quit. Easy, right? So you're going to do something very close to this in your Java rainfall assignment to handle bad input. Yeah. Oh yeah. Why would you want the program to continue if there was an error? Yeah, sometimes, like Stover says, sometimes not all errors are lethal. Right? Sometimes they are. Like if you're reading a file that shouldn't have errors in it, there's an error in it, you just quit. You know, like, nah. But what if you know, you're Mr. Excel, writing Excel, the program that bears your name, and somebody types in a bad cell reference or something. Like people would be mad at you if Excel just quit. You know? Instead, what you do is you pop up a dialog saying you have a self-referential cell or something like that, and then you just move on with your life, you know? So, I apologize, you got gardeners outside. But like, yeah, let's say you've got Excel open here, and I'm going to call a function that doesn't exist. It doesn't kill Excel, right? Instead, it's like, it pops up a little error, it's like, I've never heard of this. Never met this man in my life, you know? Easy. Yeah. Or if I'm going to be adding up all of the values above me, cool, the sum of 1, 2, and 3 is 6. But what if I include myself in the sum? That's an infinite loop. Pops up a dialog. You see that? I can't click out of it. There's one or more circular references where a formula refers to its own cell, and then it just returns 0, which is funny. That's what we were just talking about, right? So, fix it. You know, so that's how professional. It didn't just like quit. You know, people would be mad at you if it just quit. Although in the previous version of Office, which was like 2014, I think, I had Microsoft's telemetry blocked at the routing level. So if you ever tried contacting Microsoft spy, you know, servers basically that are getting uploads of the programs you're running on your machine and stuff like that, my system would block it. Because I'm like, they don't need to know what programs I'm running. I was kind of annoyed when, you know, I go to websites like, you've been playing Path of Exile this week. I'm like, the hell, Microsoft? The hell are you doing? You know? And so I blocked Microsoft's telemetry servers. And that caused Office to start crashing because they didn't... they assumed that if the internet was up, that they would be able to contact the Microsoft telemetry servers. Incorrectly, as it turns out, because I was online and had the telemetry servers blocked. And so if I went to go like save something or something, it would actually quit because it would try connecting to the telemetry servers to notify Microsoft that I was saving a file, which they absolutely don't need to know. And then the connection would fail, and then their code was set to just quit. And so there's a lot of parts of Microsoft Office I couldn't touch because if I clicked anywhere on that menu, it would just bloop because it tried contacting the telemetry server and the connection failed, and then their code was just like exit, you know, and it annoyed me. It really annoyed me. Whereas the correct thing to do would be like, oh no, I can't upload what Kearney's doing. Oh no. And then just move on and allow me to save or whatever, you know. So I had to save using Control S instead of using the menu because the menu would literally quit. It might have been because I had OneDrive blocked or something like that as well, because I had a lot of things from Microsoft blocked, but their code was utter garbage because it would just quit if it couldn't connect to a certain website, which is it's garbage not just because like you might just be like, well, just don't block it then. Well, no. What if their server goes down? You know, do you want people's Office crashing and losing their data if your server goes down? There is no guarantee the internet will work at any given time. You know what I mean? You could be on a cell phone or something, you know, and you could be on a laptop on a cell connection, going through poor connectivity. Is like my whole thing about privacy aside it is absolute garbage that it was designed that way. So, so yeah, and so their code just quit, and it shouldn't have. It should have just been like, oh, I can't connect to this telemetry servers. Okay. And the updated version of Office did that, and it doesn't crash anymore because presumably people complained about that. All right, so yeah, Kearney's read.h tries and catches. Yeah. In fact, that's what you're going to do in lab time. Is that you're going to write a function that will do something very similar to my read library. Okay. So yeah, try and catch. You try running a block of code. If an exception occurs, you catch it, print an error message, and then you can either quit or not quit. It's up to you. Do you guys understand this? And then your code can either throw something directly, or it can call. You can call functions that throw. Either way, it works the same way, because thrown exceptions go up the call stack. They go up every scope looking for a catch block. So it doesn't matter that @ is throwing versus me throwing. It doesn't matter. Either way, the exception is going to get caught. So it prints out hello world 5 times, then it prints exception caught, get help. All right. Any questions about the syntax of this? This will be on your last competency exam now. I think the 12 o'clock section for that. And so make sure you understand, because you're about to do lab time. You're gonna get about an hour's worth of lab time to do something. So if you have any questions about how this works, now's your chance. Okay. Microsoft spyware. Yeah. Okay. So the function you're going to write is going to be called nextInt. Why? Because you're going to implement something similar to my readlib, but basically how Java's next function works. Okay. So throw is necessary for catch. Try is not necessary for throw. Try is necessary for catch. You cannot. The only thing that's necessary is a catch has to follow a try. Throw is not necessary for catch. If I had no throws in here, this is fine. It just tries running it, everything runs. It just prints out hello world a bunch of times. It's fine. If you don't throw anything, you don't throw anything. It's fine. You do not have to have the throw. But a catch has to follow a tryBlock, because the tryBlock here says if an exception occurs within my boundary, then catch it. And these catch blocks, there's different catch blocks, depending on if you throw an exception, if you throw an int, or if you throw anything else. Usually it's just this. 99% of the time you throw an exception, you catch an exception. Necessary catch must follow a tryBlock. That is correct. That's the only thing that's necessary. You can have a tryBlock with no catch, although I don't know why you do that. You can have a throw with no try catch. You can have a try catch with no throw. Yeah. Okay. So your function is going to do nextInt. So what you're going to do is you are going to read one character at a time from the standard input using cn.get. And if the user enters a number, like they type in 412, you return the integer 412. So you're going to read one character at a time. You cannot use no double right arrow. No double right arrow. Okay. Which does this, right? So if the user types in 412, hits return, then you return the number 412. Okay. Make sure you take notes and code along. Error handling is super important. Yeah. Now, if the user enters a non-number, like 512, you throw an exception. Okay, even though there's a number in there, this is not valid, right? The rule is the first letter read must be a digit. So if you type in 412 like that, you return 412. That's actually how it works in C++. So if the user types in 412 you return 412 with double right arrow. That's what it does. Okay, but if you type in squirrel, I want you to throw an exception. If not, throw an exception. Okay. And once you get that working, get negative numbers to work, like negative 1,000, or squirrel would return negative 1,000. Okay. But negative, 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 negative 1,000 is throw exception. Okay. So that's what you're going to be doing. You can also write a function called bool has next int. This is also a Java function. Returns true if there is an int in the input buffer. False otherwise. Doesn't touch the input buffer. Doesn't modify, I should say. Still in class, nice. Okay. So, you're going to have 45 minutes of lab time to do this. Please don't sit there and stare at a blank screen and do nothing, because the whole point of lab time is to have you actually coding and writing code, and when you get stuck, ask a question and work on it. Like only like 3 people in the previous class actually wrote code. Everyone else just sat there for an hour. So don't do that. Okay. And this is the last day of class too, so this is your last chance to practice prior to winter break. We'll talk about winter break and CSI 41 in a little bit, but over break, go to learncpp.com and review for CSI 41. CSI 41 is not a hard class. It's just basically the continuation of this class. In fact, in this class, we've already covered a good chunk of 41 just because we went quicker than normal, because you guys were doing pretty well. So you already have actually a good chunk of 41 under your belts. It's no harder, no easier than this class. But if you don't know like for loops, you're going to have a bad time in 41. You know what I mean? If you don't know functions, you're going to have a bad time in 41. So go to learncpp.com, run through it, make sure you understand the basics. Okay? CSI 41 is going to be important. A lot of your interview questions come from there. Yeah, more than that. It's first half, second half of learn to program. It takes a year to learn to program. And it's just the second half. If you're in a major that has you learn CSI 40 but not 41, you're gonna, like math majors. A lot of times, math majors take 1 semester of computer science, and then they're like, "Aha, I'm done with it." Psych. Guess what happens when you become a junior and senior in math? You're doing programming, and if you haven't taken CSI 41, it's dead. Deadly, right? Because learning to program is 40 and 41 together. Okay. All right, so if you don't have a good foundation, CSI 26 will, it's just a train wreck on top of it. Imagine trying to do algebra and you just never learned what a variable is. like you know, it just is this train wrecking into something, train wrecking into something, train wrecking into something. You got to get the basics down. So yeah, cpp.com, learn at cpp.com is a good resource. Go through your side books again, write code, things like that. Okay, so I'm gonna pause the stream now, and someone's calling me, so it's a good time to pause. All right. Hello. We're now unpaused at 3:45, so let's do this. All right, so we need to get characters over and over again. All right, so let's probably throw this into a loop. Strategic pause while I sneezed. So yeah, getting the sign is the tricky bit. All right, so we're gonna get a character one at a time. Let's just start with this simple. I'll show you how I would do this if I was in your shoes. Get a letter at a time, and let's just cover the base case, like the most basic situation of just they type in 1, 2, 3, hit return. Okay. To get a character, we convert it to a digit. If it's a digit, if is digit C. So if they typed in a 1 through 0 on the keyboard, which is actually the order it is on the keyboard, 1 through 0, then we convert this to a number by taking the thing and subtracting ASCII code 0 out of it, because ASCII code 0 minus ASCII code 0 is 0. ASCII code 1 minus ASCII code 0 is ASCII code 1 is 49, ASCII code 0 is 48, right? So if you look at the difference between them, it's a very simple way of converting between a character holding a single digit and the number that thing represents. So we got that. So then what we do is like we sum times equals 10 and sum plus equals x. So this is how you build up a number one digit at a time. Like if you read in 123, the first digit you read is 1 and the starting sum is 0. So sum times equals 10 is still 0. We add 1 to it. We then read the 2. 1 times 10 is 10. Add in the 2, got a 12. 12 times 10 is 120. Add in the 3, 123. Once we get something that's not a digit, we're done, and else we will return the sum. So that doesn't handle all of the random conditions and stuff like that, but it is good enough. So let's see out next int and just verify that this works. So we type in 123, red 123. Okay. And why is it doing this? Do we have a see out in here somewhere? Interesting. All right, let's do this instead. 1, 2, 3, red 123. 420, red 420. AAAA, red 0. Okay. So the problem is we don't want to return 0 if the user didn't type 0. That's what exceptions are all about. There's no integer we can return here that would make any sense. So what we need to do is we need to throw an exception instead if nothing was read. So I'm just going to make a variable here to keep track. Did I read anything? Read something. And so anytime I read a character, I will set read something to be true. And then at the end here, if I read something, I return the number. Otherwise, I throw. I'll throw a runtime error or something. I don't know. throw a runtime error, no integer read or something. And there we go. So that's, so you start with the basic functionality, you then expand, This is something that no integer read or something, right? And we can catch it down in main if we want, but either way, killing the program is fine too. So you can see how that works. You start, like, that's the general approach you should always take when doing computer science. Start simple and test and make sure that your code's working and build up from there. Don't try and do everything at once. I was working with a student earlier today who writes these big long programs, and when they don't work, it's just like, why? You can have different guesses as to why it's not working, but you got 100 lines of code. Any of them could be the problem, you know? And it's just like, help me, professor. It's like, you know, the problem isn't the bugs, actually. The problem is when you write all this code at once, you don't know where the problem is. You know, you have to start with something small like this, and, you know, like, there was a minor bug where it was like printing the read before the thing read, and then it had this weird formatting thing, and so I immediately found it and corrected it. You know, not a big deal. When you're only writing this much code, it's really easy to find out where you're going wrong. It's going to be here. You know, it's in these 5 lines of code. So that's a general philosophy you have to take when doing this. And also, everybody please post your source code during lab time here. Hopefully everybody wrote something. This will be on your final competency exam. So make sure you try to understand exceptions. Let me see that source code. I think you've seen it, Betancourt. You were in office hours at the same time. So next would be hyphens. So if we get a hyphen, then if we get a hyphen followed by a number, that's fine. If we get multiple hyphens, not fine. Okay, let's do this. Bool negative, oops, bool negative equals false. Yeah, I gotcha. Betancourt. All right. So let's see, if we read a negative, okay. So if the character equals hyphen and the sum is 0, because it only works, like, you can't do 5 minus 2 or whatever, right? It has to be minus 5. It has to be the first letter we read. So it has to be and sum is 0, and we haven't read any hyphens yet either. And negative is equal to false, or not negative. Then negative equals true. Otherwise this, otherwise that. Okay. And then, yes, this will only work if we are on the first letter, and we haven't read any negatives yet, because technically this doesn't change the sum at all. So we have to check for both of that. So if the very first letter is a hyphen, we're good. Otherwise, it'll be done. If you do 55 minus 123, it'll return 55. Okay, and then when we return, we just have to check to see if it's negative, if negative is true. So if it's true that we have a negative number, we return -1 times sum. Otherwise, we just return the sum. Okay, so this is again the ternary operator. This is saying, is negative true? That's what negative question mark means. Is negative true? If negative is true, then we return the negative value of the numbers we read, -1 times. So if they typed in -555, sum is 555, so we have to return -555. Otherwise, we return 555. Okay. So that should do it. Let's test the code, of course. -555, -5, whatever. I can type, I swear. All right. Minus minus, terminate, -10, -1, -10, -10, AAA, -10. Okay, works fine. And if it didn't work, then you would know that it was those 3 lines of code that the error is in. You know what I mean? Like that's the approach you always have to take when coding. And you can maybe get away with it in C-Sci 40. You can't get away with it in C-Sci 40 and 26 if you don't have that incremental approach towards coding, where you write a little bit at a time and test it. And you always have your code in a state that runs, it doesn't crash, bounce checks properly, all that kind of stuff. It's just a habit you have to get into. Otherwise, once you start writing big chunks of code, like just nothing works. And it becomes very difficult to debug and very difficult to, write, nothing works, and you start randomly changing code left and right, hoping something will work, and it doesn't, and it just gets worse, and you get very frustrated. Like, you can write code that takes 8 hours, you can write code that takes 30 minutes, I can tell you I'd rather be the person that spends 30 minutes on a homework assignment than 8 hours, and the main difference isn't intelligence, it's not experience, although sometimes you might know about a function that somebody else doesn't know. It usually has to do with just your approach towards writing it, and just working on that, breaking it down into a small enough piece that you can test it, debug it, coming up with test cases to test your code to make sure that it works right. You see I was checking positive numbers, negative numbers, positive numbers with hyphens after it, like there's a lot of combinations, and you have to try all these different combinations of a hyphen before, hyphen after, letters before, letters after, nothing but hyphens, so that's the approach to take. Decline this. Okay, so this is the end of the semester. What we have during finals week are no finals. I'll still have office hours, Monday, Wednesday. Friday's the semester's over, so there will be office hours on Monday and Friday if you need help with anything. The last competency exam should go up about tonight by midnight, and then I'll look at whichever competency exams we haven't had 4 takes on it yet. We'll do those. The takes 3 and 4 on competency exams won't require you to do a session with a tutor. I'd still recommend it, but the tutors are students too, and I don't want to stress them out during finals week. So feel free to message me if you have any questions about the topics. Like I want to know more about functions or whatever. Just message me and I'll go over it with you. So thank you all though for coming out this semester. Next semester, 41. We got 60 people enrolled. So out of the 80 that started this class, looks like 60 are moving on to 41. So that's pretty good. That's a 75% retention rate, which is not bad. At other schools, it's around 15%. So you guys actually did pretty well. And just keep at it. Just keep learning, keep practicing. Like I said, there's a website called learncpp.com. It's got essays and ways for you to practice your C++ knowledge. You should write code over the break. Make sure you back up your files. I'll post a guide on Discord on how to back up your files, but basically just have a copy of all of your homework because I wiped the server over winter break. So make sure that you have all your homework backed up. They have a 45% retention rate. That's better than it used to be. I have all the stats. And if you're on the wait list, I will add you. I add everybody. I'm an idiot. So it's just more work for me, and it makes all the difference in the world to students. If you're trying to graduate, sorry, not gonna let you in. I let people in until the fire department doesn't, and for an online class, there's no limit. So whatever, just add everybody. I don't care. 10% from 41 to 26. Yeah, that sounds about right. Yeah, the retention rate is bad. It's bad. There are 2 sections of 41 in the spring. There is an in-person at 12, and there's an online at 2 or something like that. Don't quote me on that. I don't have it off the top of my head. More work for the auto grader. Yeah, well, the auto grader thing is not a big deal. It's the projects, right? And I need to I think I've got most of the projects done. I think I have Pokemon Part 2. There's some of those still to go. So I'll have to double check to see if I finished those or not. I don't think I have. So RPG 41 coming down the pipeline. Yeah. Yep. So there is going to be a workshop here at 4 o'clock. We'll see if JT is available. Message him. We'll do an extra credit workshop right now. I'm probably gonna have to go get my kid out of daycare once JT starts up. But yeah, no. So overall, yeah, I hope you guys had a good time. This was the basics of programming, and I know you guys worked hard this semester on it, and hopefully you picked up some skills, and we'll keep building on those skills in 41. And by the end of 41, you'll be ready to get a junior position as a programmer, even though you might not feel like it. That's why it's called the junior position, not a senior position. Right? So, good luck, and I'll see you guys next semester. Peace out.